Hello friends, Mr. Kyle Myers Mathematics, and let's just jump right into it. So today I want to talk about surface area of a cone. So this video is twofold. One, I want to talk about where the surface area formula comes from, and then two, just kind of work out some problems. A couple that are like pretty straightforward, and then a couple that maybe are a little harder, where you have to do some other stuff first before you can actually figure out what the surface area is. So without further ado, let's go ahead and jump into the first thing, which is where the formula comes from. So let's talk about what the formula is first. So surface area of a cone is going to be pi r squared plus pi r L. And a lot of times, at least in my experience, what I've seen is a lowercase cursive L, because a regular L looks like a 1. So I guess you could use a capital L if you wanted to instead, if you're not a fan of cursive, but that's what that is, pi r L. L meaning the lateral length. So on a cone, this is what that would look like. Attempt to draw a cone here. So there's my cone. There's the center. So my radius would look something like that. There's my radius, and I'll use blue for that. So here's my circular bottom. So there we go, R, radius. And then L for lateral length. So the lateral length is not the same thing as the height of the shape. The lateral length is the slanted height. So that would be L. And then of course it goes all the way around. This is also the lateral length over here. So there you go, there's your formula. And then you're probably thinking like, okay, like if you've seen this formula before, first of all, I had what I was thinking is you've probably seen this formula already if you're in geometry, and you're thinking, okay, that's the formula, but I'm not that great at formulas. How am I going to remember pi r L? Like, how does that even make sense? Well, since it's pi r squared plus pi r L, it's actually not too difficult because you can kind of do the little play on words. There's a little bit of rhyming there. Very, very similar. It's basically pi r r and then pi r L. Like you just have an R and then an L, and then the pi r part is the same. So it's not too difficult to remember. I would probably just bank on remembering the formula instead of where it comes from. But if you're interested, this is what happens. So if I want to know pi r squared, by the way, is the fairly easy part. What you're saying is, I just want to know what the area of the circle is. Right? So that's what the bottom of this cone would look like if I flattened it out and wrote it in 2D. Just be a circle, right? So area of a circle, pi r squared. And I'm definitely not going to show you where that comes from, because that would take much longer. But you also have this other thing. So if you've ever taken a soda can and unraveled the wrapper on a soda can, it becomes a rectangle, right? Well, it doesn't become a triangle, unfortunately, when you unwrap the cone part. So for instance, if you've ever had like one of those cups, those little water paper cups that you use to like put water in from a dispenser at like a doctor's office or something, if you've ever seen one of those, what you could do is basically you would cut it just one straight line from the top of the cup to the tip, and if you unraveled it, it would basically look like a pizza slice, is what it would look like. So it's basically just a piece of a larger circle. So it would kind of just look like that, is what it would look like. So this would be a piece of a larger circle. Right? And then we just want that portion of it. So what we're looking for then is what's called sector area, which if you're in geometry, you would have learned this a little earlier before you got to this unit. Sector area just means a piece of the area of a circle. So I want to do pi r squared, but then I would just want a piece of that area, so times theta over 360, or if I'm using radians, theta over 2 pi. It doesn't really matter too much whether you're using radians or not here, and you'll see why in a second. But this wouldn't be an r, though, because I already have r. R is over here, so this would actually be pi l. L is the radius of this larger one, so it'd be pi l squared. And that would be the area of that. So area of this is pi r squared. Area of the green guy over here is pi l squared. So now let's get into what that would look like. Well, we don't know a lot of things here. We don't know what this theta is. Nope, I meant to do that in green. We don't know what that theta is, but we do know what the length of this is. Right here, that length is actually the same length as the circle. So this length right here is the length of the circle, aka the circumference, which is actually the same thing as the arc length. So this is where the reason why pi rl exists gets a little tricky. So bear with me here. I've got the the sector area formula already. The sector area formula is pi l squared times theta over 360. The arc length formula, so let's say capital L arc length would be 2 pi r or pi d, right? So the circumference, arc length is a portion of the circumference. So if you want arc length, then you would do circumference times the portion that we want, theta over 360. So now we've got two different formulas. And by the way, this wouldn't be just r, this would be an L, because L, cursive L, is our radius of the circle that we're looking for here. Now we do know what the arc length is already, though. We know the arc length is the circumference, the full circumference of the blue circle, which is just 2 pi r. So 2 pi r is equal to 2 pi l times theta over 360. So now that happens. So the arc length formula is going to be 2 pi r times theta over 360, but in this case the radius is the L, so it's 2 pi L theta 360. But I already know the length of the arc is the circumference, the whole circumference of the smaller circle. So a piece of the circumference of this larger green circle is the same thing as the circumference of the smaller circle, and that's what's the tricky part. So again, I'm not recommending you know this by heart, but I'm going to just show you this because I think it's interesting. I would recommend just remembering, hey, pi rl, pi r squared, pi rl, pi r squared, pi rl, pi r squared, pi rr, rr, like a pirate, pi rr, and then pi rl, pi rr, pi rl. So anyways, 2 pi, got pi r on the brain now. 2 pi cancels on both sides. I can divide both sides by 2 pi. So then the radius of the smaller circle is equal to the length of the radius basically of the larger circle, the slanted length, the lateral length, times theta over 360. And again, I don't know what theta is, but you don't need to know what theta is because, check this out, the area of the sector is pi r l squared, pi l squared, or pi l l, right? L times L is L squared, theta 360. Now check this out. If I do this, L times theta over 360, that's exactly what R is. Look at that. L times theta over 360 is the radius. So this is pi L r, or if I write it in the way that you normally see it in books, it's pi r L. So there you go. And that's why you don't need to know what theta is. That's where the formula comes from. So there you have it. So I hope that was interesting. Let's go ahead and dive into some actual practice. So I'm going to scroll down a little bit here. So let's say we have a little bit more of a messy cone. Let's say the lateral length is 10, the radius is 3, and I want to know what's the surface area. What's the saw? Saw, dude. We want to know what the saw is. So surface area of the cone, pi r squared. Pi r squared plus pi r L. You just use the formula. Pi r squared plus pi r L. Pi times 9 plus pi times 30. Well, this is just 9 pi plus 30 pi, which is 39 pi. And of course you could type that into a calculator and it would tell you about what that is. 39 is almost 40 and pi is basically 3. So your answer would be around 120, give or take like 5. So around there if you plug it into a calculator. But 39 pi is fine. As an answer, is actually more correct than trying to type it into a calculator. So there you go. That's it. That's all you do. Let's look at another one here real quick. So let's say radius is 4. Lateral height is also 4. Right? So go ahead and pause the video if you want and try to work it out. So I'm going to do pi r squared plus pi r L. In this case, they're going to be the same thing. R is 4, so 4 squared, times 4 times 4, which is 4 squared. So this is going to be pi times 16 plus pi times 16, aka 16 pi plus 16 pi. 16 plus 16 is 32. So there we go, 32 pi. All right. So now let's look at another example. Let's say this time that you're given the height is 4 and the radius is 3. Okay? Well, if that's true, you still use the same formula. The formula didn't automatically change before. It's pi r squared plus pi r L. But I don't know what L is. You don't use 4 because 4 is not the lateral length. You have to use the right numbers for the job. Just because they didn't give you the thing that you need to use doesn't mean that you can use something else automatically, right? So be careful with that trap. I've seen a lot of people do that. Like, oh, like maybe they wanted me to use 4 instead here. They don't. What they want you to do is do some big brain stuff and figure out what the lateral length is. And you can. If you can imagine this here, and I'll try to illustrate this so you can see it a little easier. Here's the base of the right triangle. Here's the height of the right triangle. And then there's the hypotenuse. So I have a right triangle. If I have a base and a height, then I have a right triangle, I have a right angle, and so I can make a right triangle out of that base and that height. So I just need to use Pythagorean theorem. 3 squared plus 4 squared equals c squared, and this is c. Now, if you've noticed your Pythagorean identities, or triples, I should say, Pythagorean identities has to do with sine, cosine, and tangent, actually. So strike that. But Pythagorean triples, aka whole numbers that complete the Pythagorean theorem equation. So in this case, 3, 4, and that's right, 5. You're so smart. You're pretty awesome. You know that? Anyways, so 3 squared is 9, 4 squared is 16. You can do it the hard way if you really want to, right? So c squared, square root, square root. But yeah, that's a 3, 4, 5 triangle. So that means c is 5, and instead of calling it c, let's just call it like it really is. That's L. That's the lateral height. So there we go. It's 5. So pi times 3 squared plus pi times 3 times 5. So pi 3 squared is 9, right? 3 times 5 is 15. So that's 9 pi and 15 pi. 9 plus 15 is going to be 24. So 24 pi. And there we go. We're done. Right? And that's as hard as it gets. So I'm not going to do another problem like that because you would just do Pythagorean theorem. I did 2 of the previous ones just to kind of get some extra practice there. But this one I think is, well, I don't know. We'll do one more, I guess. But you can kind of see the gist already, so I'll just do another Pythagorean triple to save time here. So let's say this is 5 and this is 12. Right? So then the lateral height would be 13. That's a Pythagorean triple. I'll just call this L for right now. This is equal to R. So the Pythagorean triple would be 13. Oh, just go ahead and put 13 here. So I'd have pi times R squared plus pi times R times L. So pi times 5 squared plus pi times 5 times 13. Right? And then there you go. So you could just keep going into the answer. This would be pi times 25 plus pi times, let's see, 65, I want to say. Half of 12 is 6, so 65, yeah. 65 and 25, that would be what, 90? So 90 pi. And then, of course, if you didn't know that was also a Pythagorean triple, that's fine. 5, 12, 13 is a little bit less known than 3, 4, 5. You could just use Pythagorean theorem. 5 squared plus 12 squared equals c squared. 5 squared is 25. 12 squared is 144. Add 144 to 25, you get 169. Square root of that is 13. So there you have it. And that's how you use the equation. And earlier I showed you where the equation comes from. I wouldn't recommend trying to derive this equation every time because this one takes a little bit longer to derive to show where it comes from. So it's much more helpful to just remember the formula than to remember where it comes from. Pi r squared plus pi rl. All right, so I hope this was helpful. If it was, go ahead and give a like and subscribe to see future videos. I have an awesome free guide that I'd like you to have. It's called 5 Math Mistakes That Everyone Makes and How to Avoid Them. It's awesome. You should grab it. It's free. It's on my website. And it's just a little PDF guide where I just narrow down the 5 things that people get wrong. And of course, the 5th one is like super general because, math is very expansive. But there are very good 5 things to think about when you are going into a math problem. And the first one is very specific. So I start from specific and kind of get to more general. So go ahead and check it out. It's free. It's on my website, myersmathematics.com. Link in the description below. And I will see you in another episode.